on area between two curves. So I feel like we need to hit that just a little bit more, but I'm going to add a little bit to it if that's okay with you. Okay with us, Miss McGee. This podium has an odd note. I think I'm gonna. I was thinking about this driving in this morning. Two curves. All right, two ways we can do this, and I'm just gonna outline, give you step by steps, and we'll work some problems. I think that'll be easier with this because we kind of already touched on it, but yeah, not really. So I can do this two ways. Okay, I can do it with respect to the x-axis or with respect to the x variable, or I can do it with respect to the y-axis. Here's what I'm going to do. If I'm with respect to x, remember this is area between two curves, so I might look something like this, and I'm trying to find this area, right? So to do that, I'm going to do the integral. This A and this B are the points where these two curves intersect. Oh, it looks like a fish. Does that make sense? So it could be that I have to find or calculate those intersection points. So I'm going to go from A to B, and I'm going to do the top curve. This is not very proper, but minus the bottom curve. And of course, this is going to be with respect to x. Now, I could switch it up without going into all the gobbledygook of y. Let's say I had let's just flip this on its side. For whatever reason, this is the area that I'm trying to find. I don't really have a top curve and a bottom curve now, right? But I can do this with respect to y. So in other words, here, instead of these equations being, over here, these are going to be y equals blah, 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 x, whatever, right? Over here, I solve them for x instead of y. So x equals blah, 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 whatever y. And what I'll do is I'll do the integral from a to b again. But this time, remember, I'm with respect to y. And I'm going to do right curve minus left curve. And that's going to give me the area in between. Area in between. Does that make sense? Okay, let's do some examples. Let's do I'm going to do kind of an easy one first. And we can use our calculators for these too. Some of them lend themselves to calculators. And sometimes we may have to break some areas up. Let's say, this is a good one, find the area between area bounded by and the x-axis. So let's graph it and let's look at it and let's see what's going on. That way I can tell what I need to do, if I need to do it with respect to x, with respect to y, how I need to do this, what's going on. So I'm just going to, since this is a pretty easy, it's bounded by the x-axis also, so I'm not going to go below the x-axis, right? And then the square root of x just looks like this. And x minus 2 down 2, so let's see, come on. What would be my x-intercept? 2 with a slope of 1. It's going to look something like this. I didn't do the bottom part because I know I'm cut off at the x-axis, right? So I want the area that's bounded between the two curves and by the x-axis. So can you visually see the area that I'm looking to find? So I'm going to do this two ways for you. I'm going to do it with respect to x and then do it with respect to y. Show you that it's the same thing. But respect to x gets a little tricky because I don't really have, I mean, I do, but I can't really do, can you see where the problem's happening, top curve minus bottom curve? If I do top curve minus bottom curve, I'm going to end up with some other stuff over here, right? Because this is continuing to go this way. Does that make sense? So, and I don't want to pick that up. So what I'm going to do is I'm going to cut this function here. And I'm going to find two different areas. I'm going to find area 1 and I'm going to find area 2. Do you see why? Because here, I can just find, this is just square root of x, right? There's no other function. And by definition, the integral is from that curve down to the x-axis. So to find area 1, I need to find this point. Agreed? Well, we know that. What is it? 2. So I'm going to go from 0 to 2. What's my function? Square root of x dx. Does everybody see why we did that? That makes sense. It's a lot of thinking for an early Tuesday morning. Now area 2, and I'll evaluate it in just a second. Let me just get my integrals here set up. Area 2 is where I really have to kind of come in and think just a minute. I know I'm going from 2 to what? How do I know? What am I doing? Where they intersect, right? So where do they intersect? So maybe I use my calculator, or maybe I can just say, where is the square root of x equal to x minus 2? 4, right? Make sense? Top curve minus bottom curve, because this does have the 2. If I just did square root of x, right, I'd be going all the way down to here, and I don't want to go all the way down to there. I want to take out this extra. So I'm going to do top curve, which one's on top? Square root of x, and I'm going to subtract x minus 2. Does that make sense? So really this is from 2 to 4, square root of x minus x plus 2 dx. And what I'm going to do is just add these two areas together. Well, let's do it. Antiderivative of square root of x is what? There you go. Evaluated from 0 to 2. Plus, again, 2/3 x to the 3/2 from, or actually I can just do this. minus, what's the antiderivative of x? Plus antiderivative of 2. This is going this time from 2 to 4. So evaluate that. Plug it in. See what you get. This is just a bunch of bleh. Obviously, you don't have to plug in the zeros if you see that it's going to be 0, but just for the sake of example. Well, but here's what I'm looking at. This is the same, a positive and a negative. And that was what was going to give me trouble, right? I'm going to do away with those. Anything else? That might be it. But that was my really, because I was going to have a square root of 2, right? Or square root of 8, which is 2 root 2. Anyway, that's gone. I saw that immediately and thought, okay, I'm just going to knock that out because I don't want to even deal with it. Well, because they were the same, and this one's positive, and this is subtracting this one, so they cancel each other out. Now it makes everything a little bit easier to work with. That's obviously 0. So now I have 2/3 times, well, the square root of 4 is 2, and 2 to the 3rd is 8. So this is really 8 minus 4 squared is 16, and half of 16 is 8. Well, look at there. Minus, this one's gone, negative 2 plus 4. Did I do that right? That would be, I got 10/3 for my area. What happens though, because I want you to see how much easier sometimes it is. It's not that, I want you to see sometimes it's easier to do it with respect to y, even though it's not as familiar to you. Because this was a lot of work. We had divided into 2 regions, we had to look at it, but if we had done it with respect to y, watch what happens. Y'all got all that? Take the same example. Now, I know, let me just regraph it. Something like that. Doesn't have to be exact, just so that you can see this is square root of x. This is 2 minus x. What is 2 minus x? X minus 2. I'm going to say that this definitely does not have a negative slope. Okay, now we're good. Now, remember, when it's with respect to y, I need my equation solved not for y, but for x. That's going to be the tricky part here. So instead of calling this y equals x minus 2, I'm going to call it x equals what? Oh, I'm writing on the wrong one. Sorry. This one, I was like, no, it's not. Okay, sorry. This one's going to be x equals y plus 2. This one's going to be y squared. It's just got a domain restriction on it, right? Y is going to have to be bigger than 0. Y'all okay there? Now I can integrate with respect to y, and I don't need to break it into regions. I can just do right curve minus left curve. So I can do, what is my y going from? And that, what's this point? Let's identify that point. We already said it was 4. 4 what? Whoa. So I'm going this time from 0 to 2 because I'm looking at the y values, not the x values, right? Everything's y. This is with respect. What curve's furthest right? This is the part that always confuses me, is knowing, do I do right minus left or left? Because it seems like you do left minus right, right? But you don't. You do right minus left. Rambling. So which one is the furthest right? This one, right? But you got to do it with the solve for x, not solve for y. So it's going to be y plus 2. And now I'm going to subtract the one to the left. Y squared. Already this looks way better than the one I did before, right? A lot easier. Now the variable doesn't matter because the dy is there, the y's are there, and I just integrate as normal. So this is going to be, the antiderivative of y is 1/2 y squared plus antiderivative of 2 is 2y minus antiderivative of y squared is, of course, 1/3 y. All of this from 0 to 2. And I hope when you plug in, you get 10/3 again. Fingers crossed. Because you're on your y's. Right? Everything with respect to y, everything's y. So instead of going 0 to 4, I'm going 0 to 2. No, 2. 4 over 2 is 2 plus 4 minus 8/3. Yay. What do you think? Sometimes yes. Sometimes they look like, let me show you this one. If you were to graph these two, all right, x cubed does this. X squared, or y squared minus 2, excuse me, is a parabola on its side. It ends up looking something like this. So I'm looking at this area. Right? And I need to decide which one's easier. Should I integrate with respect to y, or should I integrate with respect to x? Probably y. I probably would do this one with respect to y also. I can't otherwise. So I guess yes. To answer your question, Avery, I guess yes. That makes sense, what you said. let's do a little bit different example. I can't remember which numbers I had asked y'all to do. This crosses at 0, 0, even though it doesn't look like it. Find the area of the shaded region. This one's kind of obvious on what you need to do since it's already solved out for you. This one's non-calculator. Just glancing at it, are you going with respect to x or respect to y? Y. First of all the equations are already solved for x for me. Second of all, it's going to be really hard to do top curve minus bottom curve when there's not really... How do you know what points? Oh, because I didn't write it on there. This is 1. Sorry. It gives you that. No. Yeah, this is 1. This is 0. Which one first? The right one. That's exactly right. So 12y squared minus 12y cubed minus the left one, 2y squared, and I'm just going to change that now that way. Clean it up just a little bit. Negative 12y cubed plus 10y squared plus 2y. Pretty easy little polynomial antiderivative there to evaluate. I distributed the minus through. It was minus 2y squared minus 2y. Did y'all want to go read before I just volunteered y'all like that? I didn't mean to. Y'all like doing that? That sounds pretty cool. I don't know. That's the first I've heard about it when she came in. Yep. Yes. My brain. I got 4/3. I mean, yep, 4/3. What y'all got? Y'all ready to crank it up? There's a cranking. You need a brain break? Okay. This is non-calculator again. Then we'll do one that is calculator. This one, they don't give you pictures. I would say probably 75% of the time you're doing it with respect to X, but you will probably have at least one multiple choice question that will be with respect to Y, possibly a part of an FRQ. So it's good to know. All right, this just says find the area of the region enclosed by the lines and curves. That's it. No calculator on this one. Well, all right, so let's think about, let's think about what this is doing, right? They're both parabolas. Yes, this one a little bit easier to graph than this one. We'll do this one first. Y equals x squared plus 4. Just a standard parabola up 4. Up 1 over 1, up 1 over 1. Okay. Now, I know I didn't teach y'all this way in Algebra 2 because I wanted you to be precise with your parabolas and graphing and whatnot. But if you know where it starts, you can look, and this only works with the first point off the vertex, but you can plot the first point off the vertex as a slope from the vertex. In other words, see how I said up 1 over 1? Because from 4 it had a slope of 1 kind of thing. Just for the first point. Now past that it wouldn't work because this doesn't keep going, it's not a line. But just for the very first point, that'll work for you, okay? So here, I can go up to 7, 4, 5, 7, right? Because it slid up 7. And now it's going down, the slope of -2, so down 1, 2 over 1. So it's at the same spot. Even though it doesn't look like it on here because I messed up graphing, but yes, same spot. So I'm looking at this area. Okay, so first thing I'm going to do is find these intersection points because I know I'm going to need them whether I do respect to X or respect to Y. I need to know where they cross, where they intersect. If I were able to use my calculator, that would make things very easy, but since this is non-calculator, I'm just going to say, where does 7 minus 2? If I couldn't see, I'm doing this, I know you can see it on here, but just in case you couldn't, where does this equal this? So I have 3 equals 3x squared, right? I just moved the 4 and moved the 2x squared, which means x squared is 1, so x is going to be plus or minus 1, which makes sense on my graph, right? This looks like 1, this looks like -1, and I can even plug in to find the y that goes with it. I'll probably plug into this one because it's a little bit easier. It should be the same y value there, 5. Y'all okay? Mine's not to scale, though. Well, mine's definitely not. My little points don't even, there's mine. The red and the black are the same point, believe it or not. All right, are we going with respect to X or respect to Y? Y. Yeah, top curve minus bottom curve, right? That's very easy to do. Don't have to break it up or anything. So I'm going to do the integral from what to what? -1 to 1. Top curve is? It probably would help if I had labeled my graphs here. That's 7 minus 2x. The red is x squared plus 4. So I'm going to subtract then the bottom curve, which is x squared. Be careful with your subtracting because you do have to distribute those negative signs there. anybody see an easier way I could have done this? What's special about parabolas that haven't been shifted left to right like this? Symmetric about that y-axis. If I'd have just doubled it from 0 to 1, one of my bounds would have been 0. I'd have plugged in a 0 for everything. It just made my life a little bit easier. Not right or wrong. I mean, it's not wrong either way you do it. Just if you saw that being symmetrical and did it that way to make a little less work for you, then that's fine. If you didn't, so you're like, whatever are you talking about? Like if I cut it right here, right, and I just did this, but I doubled it, it would be the same. Because then I'd be going from 0 to 1. If you go from 0 to 1, right? Okay, we'll just keep going with it like this. This will be 3x minus x to the third from -1 to 1. I got 4. Y'all ready for me to set you loose? No. Henry's gonna fall asleep. He's so bored. You did this one? Which one? Okay, I didn't publish it and post it and put a due date because I was like, we rushed. Remember, wasn't it like at the very end of class we were rushed and I felt like you did. Yeah. And then I wasn't here tonight, so I just said whatever, we just go over. So if you've already done some of it, then you're ahead. I don't know. We'll just give you some. This was one of them then. Oh, well look there. So I plan to move on from this tomorrow if y'all have it good. If not, we can spend another day practicing with respect to X, respect to Y. But we'll see. We'll play it by ear and see how it goes. Otherwise, we'll move on to volumes by cross-section tomorrow, which leads us into volumes by rotation, which is my favorite. All right. Let's do. You're not excited? That's it, though. Then we're wrapped up. 2. 2, essentially, yeah. No, we spent some time on them. Yeah, volume by cross-section. Volumes, yeah. Oh, I haven't. Let's do. Yes, you know what that means? Yeah. What if she did have to play with them? That's only 7. think so. I think that's good. Oh, let's do 55 and 56 because those are multiple choice. That looks good. Wasn't that fun, y'all? Those are just two multiple choice. I like it anytime I have an opportunity for practice. I'm thinking about using this one next year. Will we give you multiple choice? Yeah. I'm just gonna warn y'all, volumes by cross section is not always my favorite, but volumes by rotation, I love it. It's like third round. So, Adam, are you done now with wrestling? And so you made it to. I'm about to swim out. It's like killing other people. That's what ours was. Or are you like Monday, Wednesday? So you don't have to go as a team.
They have team state, but we did not make it very far. We're actually really bad.
Oh, from the thing?
There's 14 people that start.
Well, that's nice though that you can make it individually.
Yeah. There's 14 people that start. So, only 2 that make it. I could. I lost it. Same guy, Jason. Same guy. The only guy that lost it.
And it's based on. So are you doing things to prepare to fight them?
I've tried to, but it's really, South it could.
We should. Why do that one? Yeah.
We should have won last year.
I
was there.
Yeah, wasn't it only like 2 points? How old is he?
Yeah, no, the score was 60 to 58. And Morgan, she had a wide open.
I think you can do it, Adam. Where's the match? I know she was mad.
Not really. I mean, whatever happens, happens.
You probably already have wrestling.
Oh, yeah, I probably wrestle like a beast. Just like a beast.
Which one's better? Who's D1 and who's D2?
South Carolina only Presbyterian. Oh my God. Only one program for wrestling in South Carolina. Like Clemson will be college. Carolina.
I thought it was when. What are you looking at? I divide that into two sections. Really? I do two areas on that. So I'd have it. And so I'd use y equals x. I'd use. So I'd probably do. I'd divide it right here. Well, the problem with, yeah, you could, and you could go from 0 to 1, you could. So you could go respect to y. You'd go from 0 to 1. You'd have to solve this one for x, right? So you'd have the square root of 4y, right? Because you multiply by 4 and then take the square root. So that would be, my picture's not very good. I have to look at that picture. Right minus left, so it would be square root of 4y minus y. Or I could do with respect to x, and I'd have to break it into two. I see it better from x. I've always been better with the x part. Well, the square root of 4y would just be 2 square root of y. So then it'd be 3 over 2, no, 2/3, sorry. I'd probably go with respect, I mean, if it's me, I'm with respect to x, and I would do I'd go from 0 to 1, and I'd do x minus x squared over 4. And then for the second part, I'd go from 1 to 2, and I'd do 1 minus x squared over 4. Either one will work, whichever one you see easier. Number 9. Should be 5, 6. Number 9. Huh, that's not what you got. Huh? I got 2, 6. That's going to be my bound because it's the y value from the bottom to the top. So it's just saying go from 0 to 1 and then do right curve minus left curve. You see what I'm saying? So that one might be easier for you to see. 2/6 again? Maybe their answer is wrong. Did you do it with respect to y or respect to x? All right, so this is really 2 square root of y. So I get 2 times 2/3 y to the 3/2 minus 1/2 y squared from 0 to 1. Oh, do I have to do with group? Like, do I have to do 2/3 minus 1/2 again? Yes. No. No. This just here. Yeah. Should be 4/3 minus a half. Well, then what happens when you do it with respect to x? I'm wondering if that square root. I wonder if the plus or minus square root had something to do with it, because if that's. You got what? Did you do it with respect? Oh, it's 5/6, not 5/3. Yeah, so this is 4/3 minus. Oh, I can't make this. Common denominator would be 6, so times 2 would be 8/6 minus. Yeah. No, I'm so dumb. I sat here and looked at it and said, "What?" And Hope's going, "I did what you did." The square root of 4, because it was the square root of 4y, so it's 2 times square root of y. Same thing for 10, 5, 6. Yeah. This is number 9, but yeah. Y'all are doing really good with this. I'm impressed.
But I mean, like, that's like a thing.
See what 14 looks like.